Hello, dear learners. Welcome into the refresher course in geography. Today, we are going to learn very interesting modern development and new dimension of the geography, which is a geospatial technology. In this technology, the geography has increased the accuracy level, increased the research preciseness to planning and management and decision purpose. That's why the remote sensing technology, not only in the geography, but it's become a very essential techniques into the modern era in all types of the disciplines. So today we are going to learn about the principles of remote sensing and its application in geographic research. Our session will be continued with the two phases. In first phase, we will learn about the principles of remote sensing. In that, we'll see the basic concepts and the major principles in which the remote sensing works. And in the second phase, we will see what the applications or what are the areas, in especially in the geography, where the remote sensing technology can be applied. In that, we are focusing on the six major areas: disaster management and conservation, ocean resource and conservation, forest and wildlife conservation, watershed planning and water conservation, agriculture geography, and in the urban geography. What are the applications are there in the remote sensing? So let's start the learn about the remote sensing. Remote sensing is a very ancient technology which we using the first human beings, and this technology we are still using in our day-to-day era, day-to-day life, right from the primitive time to the modern time. We are using the remote sensing purpose. Only thing is that earlier we were using the natural remote sensing, in which our eye works as a sensor. Our sensor gathered the signals from the objects or the objects, and that signals reach to the eyes in the retina, and the retina send the signals to the brain for processing purpose, and the brain analyze that signals and it gives the result, and he find out the object in front of the particular human beings. And still for the learning, for teaching, uh, day-to-day life, we are using this natural remote sensing. Scientists use this artificial remote sensing techniques, and they observe these techniques and they applied the same function into the artificial wave, in which the solar radiations are the big source of energy. The energy are reach to the enter into the earth atmosphere. They interact with the earth atmosphere. um, there will be a absorptions, there will be a reflection, there will be a transmission, and then again the signals reach to the earth surface. They interact with the various objects on the earth surface. Each objects interact differently to the radiations, and after interacting, before interacting, the journey of the radiations from sun surface to the earth surface is called as the insolation or incoming solar radiation. But after interaction, earth objects emit his own radiation, which called as the earth terrestrial radiation. That radiation again interact while emitting, it interact with the atmosphere, and it reach to the sensor or in the satellites where the sensors are there. That sensor receive the signals from the object, and they save into the form of digital number or brightness value. And that brightness value, digital number, sent back to the ground station for the processing. Processing unit work on this digital number, the processing on this, which called as a digital image processing. And after processing, the big image will be created, and that image will be used for the various multipurpose applications, for analysis, for decision making, for planning, for management purpose. This imageries we can use. Hence, this is very interesting remote sensing technology we are using in the geographical research. So let's see what is a remote sensing. This entire function, right from the sun to the application, the remote sensing works in a different phases. So what is remote sensing then? Remote sensing is a art and science to acquire the information about an objects without being in physical contact. And how it works? It's done by using recording, reflecting the emitted radiation and processing that radiation, analyzing and applying this information for the various applications. So it's a simple remote sensing. So let's see what is the history of remote sensing. Remote sensing took many years to develop from the initial phase of remote sensing to the modern phase of artificial remote sensing. So many changes has been occurred. In primitive age, only visual information used that we called as a, and still we are using this called as a natural remote sensing, in which our eyes work as a sensor and our body works as a platform to move that sensor from one place to another place. Okay, this is a initial development, and this same technology we are using in your day-to-day life. In artificial way, in 1858, balloon used for the remote sensing, used in remote sensing to take the picture of the Boston city. And this is a first landmark in the history of remote sensing where the balloon used. Next, in 1873 is a landmark in the history of remote sensing in which Sir James Maxwell developed the theory of electromagnetic radiation and which bring the revolution into the remote sensing development. In 1873, aeroplane used for the remote sensing application. In 1918, after end of World War and even during the World War, 1914 to 1918, the remote sensing plays a very crucial role to take the aerial photographs of the enemy countries. And after the end of First World War, the importance of the remote sensing as and the aeroplane aerial photography has increased, and that's why in 1918, after finishing the World War First, Britishers established the air shipping and transport company in India for systematic mapping of Indian territory. And even though those who are the remote area, that also they wanted to observe, make the survey, and bring this area under the British territory. In 1954, it's a renamed after independence. Air Shipping and Transport Company renamed as a Air Survey Company of India. Another landmark in the history of remote sensing is in 1972, USA launched the Landsat. Landsat is a satellite series called as a land satellites, or it's also called as a Earth System Technology Satellite (ERTS). In this Landsat series, first remote sensing imagery is captured by USA. After that, in 1986, European Union developed the Spot series. And quick after 1988, India started our own remote sensing series called as a IRS-1, which is Indian remote sensing. And afterwards, the all series are continued with the name of IRS, Indian remote sensing. Okay, so this how the development took place from the initial phase, primitive phase to the modern phase. Even though its a development is still occurring into the remote sensing. Now we'll see how the remote sensing works. What are the process are there? That process we can divide it into the seven phases or seven steps we can say. First important phase is a energy source. The sun, no doubt, predominant source of the energy is the sun. There are so many chemical and nuclear reactions occurs onto the sun surface which creates the tremendous energy, and this energy emitted into the space. and some part of this portion reach to the Earth's environment, atmosphere. They interact with the atmosphere first. Before it's entered into the energy entered into the Earth atmosphere, some energy gets scattered, reflects, absorbed, and some portion of the solar energy interact with the Earth atmosphere. They interact with the atmosphere and they reach to the Earth's surface. So third phase is a energy interact with the Earth surface. Till interact with the Earth surface, all the energy called as the insolation, as I told earlier. Insolation means incoming solar radiation. Okay, so again, every object on the Earth's surface is interact with those energy based on their chemical properties, physical properties, and some objects emit radiation, some absorb, some reflects. Okay, so based on that, the objects interact differently with the object, this energy, and then Earth start to emitting its own radiation called as a Earth tested radiation. That radiations again interact with the atmosphere while outgoing. Okay, then and after that it's recorded by the sensor. So first step is a energy recording sensor or the camera. After recording, the recording into the earlier it was recording into the um, analog and digital form. Okay, and then in digital form it's recorded into the brightness value or into the digital number DN, and that digital number transferred to the ground station for the correction and for making the imageries. After the correction, the imageries will be ready for various applications, analysis, planning. Okay, and then after analysis, the researchers, teachers, planners, engineers use this energy, use these imageries for the various application. So seven stages of application. Okay, so these seven stages are important into the remote sensing process. All the remote sensing is there in these seven stages. Another important part of the remote sensing is the electromagnetic radiations. As I told, on the sun surface, lot of chemical and nuclear reactions occurs which create the energy. That energy travel into the space in the form of electric waves. In this image, you can see the green waves are the electric waves. And because of this frequency of the electric waves, it's create the magnetic fields and they travel perpendicular to the electric fields. So electric waves are there electric waves are there, and perpendicular to this electric waves, another field creates called as a magnetic waves or magnetic field, and they travel synchronously. They synchronize to each other, and that's why this energy, this radiation, is called as a electromagnetic radiation. Combination of electric waves and the magnetic waves. Okay, and they are traveling into the form of waves, electric waves, and another is form of the magnetic waves. They are perpendicular. That entire radiations combine with the smaller wavelength to the larger wavelength. So the entire radiations on the from the sun is segregated from a smaller wavelength to the larger wavelength, and in between having the some medium sorts of the waves are there. Based on the frequency and the wavelength, this entire radiations is divided into the certain portions which is called as the electromagnetic spectrum. It is a portion into the electromagnetic radiation. Okay, so they are into the shorter wavelength to the larger wavelength. Okay, if you see the shorter wavelength started from the left hand side, in which the cosmic rays are first, which is very narrow in shape and frequency is very high. After that is the gamma rays, X rays. They are very smaller wavelength and the frequency is very high, and that's why they reflect absorb somewhere into the space before entering into the earth atmosphere. But the ultraviolet radiations are reached to the earth atmosphere And we know that on the troposphere, above the troposphere, there is a stratosphere, mesosphere, ionosphere, and the exosphere. These are the layers of the atmosphere is there. So in that, the stratosphere having the smaller thin layer called as the ozone. That ozone is absorb all these harmful ultraviolet radiations. Means the learners, friends, cosmic rays, gamma rays, X-rays, and ultraviolet rays, we never using into the remote sensing purpose because they're very narrow, frequency is very high, and they absorb, they get reflect, they get scattered into the space before entering into the Earth atmosphere. Next portion is to the visible band. Yes, visible portion is the only portion into the radiation which we can see into the open eyes by the open eyes. After that is a IR region called as the infrared region. Infrared region divided again into the three parts, three portions. Near infrared called as NIR, MIR, middle infrared, and the FIR, far infrared. After infrared portion, there is a microwave. So visible, infrared, and microwave portions we are using into the remote sensing application. Next to that is the radio waves. Radio waves are each waves are kilometer more than kilometer. This one the frequency is there, wavelength is there. That's why this radiation radio waves we are not using it to the remote sensing application. So this serves from the smaller wavelength to the larger wavelength. The entire spectrum has divided into the different portions. Started from the cosmic rays, gamma rays, X-rays, ultraviolet, visible band, infrared, microwaves, and the radio waves. Next, come to the remote sensing platform. Another important aspect of the remote sensing is to the platform. Platform is nothing but it's a stage where the camera or the sensor mount and which carry from one place to another place. Platform is just a carrier where the camera can be mount and that platform can be moved from one place to another place. Okay, so this is the stage to mount the camera or the sensor. So based on their position, there are the three types of the platforms are there based on their position. First is a position on the ground. It's called as a ground-based platforms. It's the initial development of the remote sensing where towers, cranes. Before that, the human beings are using the big trees, big tall hill to observe, to mount the camera, to acquire the information about the larger area. So that all this cameras are base touch to the ground. That's what is called as a ground based platform. Nowadays we're using the crane, we are putting the tower to monitor the larger area, right? So where the sensors, the our cameras base touch to the ground, called as a ground based platform. Another is where the base is on the air, it's called as a atmospheric or aerial platform. Atmospheric of aerial platform. Slowly human beings wanted to go up to capture the larger area, right? And for that purpose they started to put the platform into the space from ground to space, and he used the kite. On the kite he put the human being put the camera. Above the kite there is a birds, so trained birds who using putting the camera in their neck and they are moving into the certain area to capture the photographs. Above the bird is a balloon, then helicopter, aeroplane. No doubt in the World War One and first and second, the role of the aerial platform, especially the aeroplane, is very high to acquire the systematic pictures of the enemy countries or the area. Then above that is a no doubt there is a single platform called as a satellite into the space. So this how slowly the human being develop his technology to go up to capture, bring the larger area under the observation, and we reach from ground to air and now air to the space. So this how we can see the development through this imaginary picture. right? We started our platform developed from the ground into the space. Now we are using the drone. Drone is a good example of the platform. Aerial platform. The drone we can fly onto the lower altitude, upper altitude. Okay, altitude we can change as per our objective of the research. So on that, after that, there is we are using the kite, right? Then the birds, balloon, helicopter, aeroplane, and into the space we have the satellite. So these are the platforms to carry the sensor and the camera. Now come to the types of remote sensing. Based on the energy source, remote sensing broadly divided in two types. Initially, the type was passive remote sensing, in which the only solar radiation, solar energy we are using for the remote sensing application, right? So that passive remote sensing having certain limitations, because passive remote sensing we were used only till the sun in the sky, means only during the daytime we can use the passive remote sensing, but during the night we cannot use it. And the disaster like flood, tsunami, cyclone, earthquake, during that time we are not able to capture the imageries, take the photographs. And that's why passive remote sensing having the limitations of 12 hours in a day. And that's why scientists try to overcome that limitations and develop the another important technique type of the remote sensing, which called as a active remote sensing, in which the sensor having his own source of radiations, that radiations reach to the earth, towards the earth, they interact with the objects on the earth surface, and backscatter energy they recorded by the sensor. And the good example is our camera, radar, and SAR, synthetic aperture radar, is an example of the active remote sensing. Now, through this animation, we can see left-hand side image is a passive remote sensing, in which only the solar radiations are using. Now, here is the limitations of day and night. Daytime, yes, or we can use it, but nighttime we can't use it, right? So we overcome this limitation by using the active remote sensing. Right hand side image, you can see animation in which the sensor, not satellite, the sensor is sending his own beams, and they're recording the backscatter energy from the objects. Now here active remote sensing is a time independent, season independent. We can use it day and night, all seasons in a year. And that's why active remote sensing is very important in a remote sensing studies. Now come to the satellite. Satellite is a platform into the space, right? But based on their applications, based on their altitude, based on their work, so satellites can be divided into the three types. First is a geostationary satellite. Geostationary satellite is a moving parallel to the equator, and they're observing continuously observing the same portion right from its launching to its expiry. Continuously they are moving parallel to the equator, and from the equator he is observing the earth. The altitude is around 36,000 kilometers from the surface. Imagine the altitude. It's the equator orbiting satellites. Because of the high altitude, these satellites can cover the maximum portion of the earth. How much it is? It is a one-third portion of the earth one satellite can cover, and three satellites cover the entire earth. Sorry, entire earth. Geostationary satellites also called as a um, synchronized satellites. The rotation is synchronized with the rotation period of the earth, and that it is called as a geostationary satellites. It's a seems like a stable because rotation of the earth is synchronized with the rotation of the geostationary satellites, which is 24 hours. Now, what is the main use of this satellite is meteorological and telecommunication purpose. We'll see how this geostationary satellite launch. This is GSLV vehicle, geostationary satellite launching vehicle. This is very powerful launching vehicle developed by India. We are very independent in the launching our own satellite. At the top, there is a satellite. When it's reached to their defined orbit, the automatically satellites get separate from the launching vehicles. They put into their own orbit and start functioning by their own. Okay, so I hope you understood. Now come to the second type is a sun synchronous satellites. It's also called as a remote sensing satellite. This satellite we're using for the capturing the imageries of the Earth. The altitude of the remote sensing satellite is 700 to 900 kilometers. It's a low altitude satellite, and they are moving from pole to pole. So orbit is earlier satellite orbit is equatorial orbiting, but now this is polar orbiting. Why this polar orbiting or orbit is there? Because they are moving from north pole to south pole, and Earth is moving from west to east. So every pass, every time, the new area will be observation under observation, and slowly like that, the entire Earth will be covered after certain days. Now we'll see how this satellite is getting launched. This is called as a PSLV, Polar Satellite Launching Vehicle, or this is a remote sensing satellite. Altitude is very less, 700 to 900 kilometer. That's why the propellant or size of this vehicle is smaller as compared to the geostationary satellite launching vehicle. This animation of our Indian satellite launch. We have launched around 7 to 8 satellites of different countries with the help of this one launching vehicle. Earlier, the record was 35 satellites launched by the Russia, but India broke this record. Our record is now we are launched 104 satellite through the single vehicles, single launching vehicle. Now we'll see how the pole to pole orbit is there and how the satellite cover the entire portion of the Earth in under remote sensing. Now see here, Earth is moving from west to east, and this is the descending path of the satellites moving from North Pole to South Pole. This is the one pass. Next second pass, Earth rotates, new area will becomes under observation. And like that, satellite sensor satellites cover the entire Earth and sensor scan the entire Earth. And again, after certain days, the satellite reach to their original location. Okay. So the revisit period of the satellite depend on the swath, means how much area the satellite is covering in one pass. If it is covering the smaller portion, the repetitive period of the satellites means reach to the original location will be the high. Date will be the more. And the swath means one pass, they're covering the more larger portion, the repetitivity period will be less. Now, based on the scanning function, data will be stored into the different forms based on the scanning function. There are three types of the scanning sensor scanning systems is there, or it's a called as a scanning format, file format. So first is the sequential scanning. You can see the animation of sequential scanning. Now here the camera sensor is not continuously on. They are taking the scanning the area in a sequential form. Second is the BIL, band interlude by line. Now see how the line by line the area is getting scanned. Now here the sensor is continuously on and they are scanning into the forwarding motion. It's called as a forwarding looking sensor. Third types of the scanning is a band interlude by pixel wise scanning. Now these types of the scanning called as a across track scanning. The scanning into the reverse direction and the motion is in a forwarding direction. Next is a navigation satellites. It's a third types of satellites where the satellites are into the various orbits. It's a multiple orbits. There is around six orbits are there, and each orbits having the certain number of satellite. They have the and the network of the satellites where the different orbits are there, and in each orbit having the number of satellites. Normally, altitude of the satellite is at 20,200 kilometer. Six orbits are there. The number of satellites are into the range of 31 to 35. It's getting more or less. This is a constellation of navigation satellites of USA. NASA satellite constellation is there. They are using normally for the navigation purpose, vehicle tracking system. Nowadays, we are getting the or all the information, GPS information through these types of the satellite. In the world, there is a five countries having their own navigation system, in which the pioneer is USA, after that Russia and the European Union. They are having the global network. These three countries having the global network. China and India having the regional network. They are covering their country and the neighboring certain areas. India in 14, India becomes self-sufficient into the navigation system, and we give the name. Initial name was the Gagan, and now this our own navigation system called as the IRNSS, Indian Regional Navigation Satellite System. These are the three types of the satellites. Now come to the resolution. Resolution, there are four types of the resolution is there: spatial, spectral, radiometric, and temporal resolution. Here important is a spatial resolution. Spatial resolution means capacity of the sensor to detect the finest object on the Earth surface. Low resolution satellites cover the larger area, right? But they never give the high resolution. Finest object cannot detect. Yes, they can cover the larger area, but detail will be the less. For regional level analysis, we can use these types of the satellite imageries where we're having the low resolution. High resolution imagery is used for the resource planning, urban planning. This is second image, LIS 4. It's a linear imaging cell scanning, which is a moderate resolution, right? Third one is a high resolution. The resolution is a 30 centimeter. This high resolution imageries we can use for the urban planning, macro level planning. Okay, So this how the resolution is very important component of the remote sensing. You can see this another high resolution image. See the accuracy, see the view, see the high resolution imageries in which we can see the airport, we can see the aeroplane, vehicles, small vehicles also there surrounding by the aeroplane. See the satellite size around 700 to 900 kilometer from the surface, and from that much distance, they see how accurate the area is getting observed, and that's why we are called as a satellite or sensor is a eye in the sky. In future, the capacity of the sensor will be the high. Now we'll see what are the advantages are there of this remote sensing. Important advantage is first is a synoptic view. It gives a bird eye view. By looking these aerial photographs, we will feel that we are somewhere into the space and we are observing. It's called as a bird eye view. So no doubt, it's a real-time image and it gives the precise synoptic view. Another is accessibility. It is possible to get the information about the remote areas where manually visit is not possible. It's a time dependent, money dependent, manpower dependent work. But by through this remote sensing, we can easily reach to the remote area. We can easily get the information about that remote area without being their contact. Without visit of this area, we can get the information. We can get the imageries of this area. So accessibility is very high. Time conservation, no doubt. Manually survey, manually visit, mapping will be the time time consuming task. But through this remote sensing application, remote sensing imagery, we can conserve the time and enhance the accuracy. We can save the human efforts through this technology. Okay. Another important advantage of the remote sensing is the multidisciplinary applications. One image of a particular area can be used for the several application purpose. Means a same area image of a particular city. That image uh, can be used for the various applications. Means researcher can be used this for the urban planning purpose. Urban planner used, engineer can use making the various roads, dam, right? So many peoples, many experts use the same area image for the multiple application. Now come to the second part. I hope you understood the basic principle of remote sensing, right? So now we'll move to the second part in which we will learn what are the applications of remote sensing into the geography, especially in the field of geography. First, we'll see the important aspect is the disaster management, and in the disaster, important part is a flood. No doubt, every year India is facing this disaster, right? So where we can use the remote sensing? We can use the remote sensing imageries for real-time flood monitoring. During the flood time, we can observe, we can use the aerial photographs, we can use the satellite images of area to make the disaster management planning, real-time flood monitoring. Before incidents occur, the flood occurs, we can make the flood risk zoning. Every year, the certain area is submerged. So by taking this every year data, we can make the flood risk zonation map. So during the flood time, we can mark those area, and before incidents of flood, we can move the people, that area people, to the safer side. Flood impact assessment. After flood, we can take the imageries of before flood and after flood. We can make the assessment. How much damages occurs to the houses, to the properties, to the crops. For impact assessment purpose, even flood forecast modeling purpose. It's a laboratory concept. In the laboratories also, before incidents of the flood, we can make the model, and we can forecast if the some certain amount of the rainfall occurs, how much water will be in the channel, and in the channel this much water will become, how much area will be submerged. So that model we can make, and after that we can move the people of that flood zone area to the safer side. For monitoring the cyclone, this is imageries of um, before cyclone, and the right hand side is after cyclone. You can easily see how much damage has occurred. So in this before and after satellite images, if we will have, we can analyze it and we can find out how much damage has been occurred. This is also impact of tsunami into the Adyar River. This is incidence of 2004. We can see that pre-event and post-event satellite imagery. Another disaster is a landslide. We all are aware about the incidents in Maharashtra, Malin incidents. After that, government of Maharashtra has decided to make the hazard zonation map of the Western Ghat of the Maharashtra to make the risk zonation map and to avoid the such types of landslide into the particular area. So in satellite imageries, landslide prone areas will be looks like into the high reflected area, into the dark. Reflection will be the very high, and by using the different parameters we can make the risk zonation map. How much risk will be there? Landslide hazard risk zonation map. In that we can use the parameter of rocks, we can parameter of use the slope, rainfall of that area, permeability of the rock. So all these parameter we can bind, and in GIS environment we can make the model to find out the where the risk is very high, landslide risk is very high. And when we got the hazard zonation map, we can identify which area where the risk of the landslide is very high and which villages will become under that zone. So we can easily um, redivert these people into the safer area, relocate these people into the safer zone. So for that, remote sensing plays a very important role to landslide hazard zonation mapping. This is the hazard landslide prone areas in India, normally where the incidence of landslide will be very frequent. Another important is cyclone monitoring. In the satellite, we already know the geostationary satellite. It is a equator orbiting satellites. They are observing the same portion, and they are using for the meteorological and telecommunication purpose. So geostationary satellites are normally using to monitor the cyclone because they are keenly observing the same area for the longer period of time. So in which if the cyclone is originated, we can monitor of that cyclone, their movement, the speed, the direction, everything we monitor. And recently we already know that earlier the physical damage, loss of life was more, but nowadays the cyclone is still there in India, many part of India, but we are minimize the casualty of the life. No doubt property loss we cannot prevent, but yes, we have control on the loss of life through the technology. Another application into the oceanography. Oceanography is another big source of food after agriculture, right? So that's why nowadays and even into the future also, there will be the very high scope for the ocean research. What we can do into the, and many countries have developed their own uh, satellites to study specifically of the ocean water or ocean bodies. We have OCM, Ocean Color Monitor satellites, which is continuously observing the slight movement into the ocean. Where we can use the remote sensing in ocean research, oceanography, first to sea surface temperature mapping. Surface temperature control the global climate, right? And that's why we are continuously monitoring to the sea surface temperature. Wave height mapping and monitoring to monitor the tsunami condition. We continuously observing the wave height, right? Another is a PFZ mapping, potential fishing zone mapping. India has prepared the PAN, NREC, National Remote Sensing Center, prepared the potential fishing zone map of the entire Indian coast. What is the potential fishing zone? It is a map to find out the areas where the more number of the seafoods is available. Okay, this is a ocean chain normally where the phytoplanktons are there. In the satellites, we're identifying where the phytoplanktons are reach. If the phytoplanktons are reach means no doubt the insects will be there. Okay, for that small fishes will be there, large fishes will be there, and from that PFZ mapping, we are telling to the fishermen to go to the particular area for getting the more number of fish. That's why PFZ mapping is very important, economically beneficial to get the maximum fish. Tsunami monitoring and damage assessment is another important application, remote sensing application is there into the ocean research. Coastal zone management. Coastal area is a transition zone between the land and water. So continuously encroachment of the uh, human beings are there, and the encroachment of the human beings onto the coastal area, coastal zone is always a fluctuate zone, which putting the great impact onto the coastal life, coastal environment, coastal ecosystem, development of the mangroves. So many is getting changed. To control that encroachment of the coastal area, we have the coastal zone management system. And for that purpose, remote sensing images give the maximum number of the inputs. Study of the mangroves, because mangroves is a natural shield to prevent the tsunami. But nowadays, due to the anthropogenic activities, marine pollution, there is a continuously damage occurring into the mangrove forest. You can take the example of in Goa, you can take the example in India, Sundarban, where continuously the mangroves cover is getting declined. You can give the example of the pollution, marine pollution, anthropogenic activities. So to control on this, we have the specific satellite used to study the ocean bodies. This image you can see the mangrove forest. This is list image. Another important aspect is the environmental management. In that, forest management is very important. In the forest management, we can use the remote sensing for wildlife monitoring. We cannot see the animals into the imageries, but yes, by looking the forest cover, we can identify their habitat. Normally, dense forest is the habitat of the carnivorous animal. Then the herbivorous animals are grassland habitat. So like that, we can identify their natural habitat by looking the density of the forest. So forest density we can easily identify on the satellite imageries. They are looking to the dark red color. You can see this picture imageries. We can monitor the wildlife. We can monitor the location and locations of the herbivorous, carnivorous animals. Then we can monitor the forest fire. We can mapping the forest fire. Another important, forest cover is declining in a very rapid rate, not only in India, but every part of the world. The lungs of the earth, called as a Amazon forest. Amazon forest declined very rapidly due to the anthropogenic activity. In a 1 hour, around 10 football ground area were destroying. Forest area is destroyed. See, this is the rate is happening into the worldwide. So for change detection analysis, we can identify how much deforestation is occurring into the world worldwide. Not only that, this is a forest core area in India in 1972 to 75. And you can see here, it's a 8082. How rapidly the forest cover is declining in India. According to the environmental law, around minimum 33% part of the country must be under forest cover, but in India, its rate is very less as compared to the national internet environmental norms. Normally, 20 to 23% part of the India is under forest, which has to be increased very rapidly. Along with that, we can use the remote sensing technology to identify the forest types. What types of the forests are there? Along with the remote sensing, we can use the GPS system to find out the forest types. This is the forest types in Arunachal Pradesh. See how many types of the forest vegetations are there, right? Next, deforestation. Deforestation happening very rapidly in India as well as in the world. By taking this example of the Assam area, you can observe this area, this portion, very green. In it's a thematic mapper image in 1994. See this area greenery, but in 1999, after the time span of 5 years, how much area we has deforested? How much forest area has declined? And see after 2 years, this much portion. Now here in 2001, more number of forest area is now deforested. It's a part of Assam and Arunachal Pradesh. See, this is the rate of only one area and only one state, only one country. But the same things happening into the every part of the world with a very drastic rate. And it's an alarming condition. And in that, for precise mapping, remote sensing technology plays a very precise role, very important role into the deforestation monitoring and change detection analysis of the forest cover. Means after a time spread of 5 year, 10 year, how much area forest has increased, decreased. Okay, it decreased means how much decrease, rate of declination, how much it is there. If the rate is this much, after 30 years, 40 years, what will be the scene? That model we can develop. This is the shifting cultivation, forest fire. Still in North East India, many tribal communities are practicing the shifting cultivation. And it is in this image, this black color patches shows these are the zoom cultivation or shifting cultivation practiced by the tribal communities. We can monitor this area, we can measure this area. Okay, so for shifting cultivation mapping, remote sensing is very important to forest fire monitoring. Then watershed management. Water is very important resource. Maximum part of the earth is underwater, but still even there is a scarcity of the drinking water. Most of the drinking water is freeze in the frozen form, and maximum portion is in the into the salty form. So very scarcity is there for the drinkable water, and in future the scarcity of the drinking water will be very high, and that's why we required the systematic planning to control, conserve the water use. Where the remote sensing can use for the surface water mapping, underground water mapping, and watershed area management. Watershed is the smallest natural unit where we can make the planning to conserve the water, save the water. This is the portion you can see. This is the image of the area where the water sources we can see dam, we can see the river channel, reservoir. Another area of the remote sensing use in geography is agriculture geography. Agriculture is a very big source of the food into the growing population, right? So population, according to the Malthusian law, the population is increasing very rapidly into the geometrical rate, but the resources are increasing into the mathematical rate. So there is a increasing the gap between the population and the resources, increasing the gap between the population and the food. So more number of the population are depending on the available agriculture land for meeting the demand of food. Hence, nowadays we are required to use the modern tools and techniques to monitor agriculture land, to control and conserve the agriculture land, to save the soil loss, to optimally utilize the water, practice the modern irrigation practices to decline the land degradation, to conserve the land degradation. Where we can use the remote sensing in agriculture geography, first to crop monitoring and estimation. Monitoring the crop. Here we can see the agriculture area and the village. So in this agriculture patches, we can see the dark red color and the light red color. It shows the healthiness of the crop. If the dark light is there, dark red color means healthy crop. Light red color means the crop having the scarcity of the water or some diseases are there. For monitoring purpose, we can observe the particular number of a particular agriculture plot, and we can identify the which crops having the diseases or shortage of the water. So that monitoring we can do. We can use modern practices to monitor the health, and if the health is good, easily we can estimate how much production of the particular crop will be there. So crop estimation purpose, remote sensing plays very important role. Then agriculture drought assessment. India every year facing the problem of drought, and that's why India is always focusing on to the monitoring and the estimation of the crop, because we have a lot of population. If the scarcity of the crop will be there, India has to be buy the food from the other country. But nowadays we are into the safer position. We have the self-sufficient. We are the food bank. We are the feeder of the world. Okay. So drought assessment, monitoring on the crop, monitoring the irrigation practices in the agriculture area, finding the healthiness of the soil, everything we can monitor through the remote sensing. Even the finding the salinity of the crop, waterlogging area mapping purpose we are using, because all this happening because of the improper irrigation practices. Instead of the modern irrigation, drip irrigation, sprinkler, we are using the traditional irrigation practices where the more number of water we are providing, which started the waterlogging problem. Waterlogging is continuously occurring into the area, then the soluble salts will become up and they accumulate into the upper layer of the soil, and slowly the water becomes saline. So waterlogging and salinity is very harmful, happening because of the improper irrigation practices. Soil erosion mapping and monitoring also very important. Can be use, monitor, we can conserve through remote sensing application. This is waterlogging area mapping. This is the crop mapping into the Karvir Tehsil, Kolhapur districts of Maharashtra. Here, along with the remote sensing, the GPS technology is used to identify the particular crop, and based on that, the superos classification has done to identify which crops are there, and quantity and the distribution of the crop we can see. If the distribution is we got, crop we got, easily we can estimate how much production will be there in a particular area. Now come to the urban geography. This is a very upcoming and high scope of remote sensing and GIS is there into the urban geography. Because urbanization, industrialization is growing rapidly into the globalization era. Urbanization is happening, started from the industrialization, and still today the migration is more occurring from rural area to the urban area in the search of job, best standard of living. So migration is there, and because of this migration, it's putting the pressure on the agriculture land, agriculture services, and for that, remote sensing and GIS plays a very important role to systematic management of the urban area. So where we can use the remote sensing in urban geography? First, for the urban growth studies. Specific city growing in a which rate? How how was the situation of a particular city 10 year back or 20 year back, and what is it now? Now how much city has grown, and we can find out the rate of growth of the particular city. Based on that growth rate, we can estimate after 30 year 40 year how much that particular city will be expand, and which direction the city will be more expand. So that we can calculate in GS modeling, estimation modeling. Then urban change direction analysis. Urban land use is dynamic, is continuously changing. So that change direction analysis in the urban area we can use through the spatio-temporal satellite imageries. Means satellite imageries of 10 year, 20 year back compared with the current two satellite imageries, we can find out the changes in the land use land core in a particular urban area. Urban land use mapping, as I told, urban traffic and pollution mapping for the macro level analysis into the urban area, traffic um controlling, traffic monitoring, and pollution mapping. Because of the urbanization and huge tall building, the pollution level of the cities is increasing very rapidly. We have the witness of Delhi NCR, where the population is very high. Right? For that purpose, remote sensing plays an important role to find out the distribution of the pollution in a particular city. City sanitation planning nowadays, Government of India is plan develop the smart cities, and under that, government is trying to giving the facility of the sanitation, water supply, solid waste management, sewage management, and for that, GIS, remote sensing, GPS technology play a very important role in city sanitation mapping and planning. Urban tax assessment is a very another important benefit to give the economic boost to the urban local government. Where in GIS platform we can digitize every building, and we can fit the data of every house owner, and we can find out their tax record, how much tax has paid in and how much tax is pending. In a one click we can get the all information about a city. If the tax is pending, we can send the notice to them. That magic is happening because of the spatial and non-spatial interaction, spatial and non-spatial integration of a data into the GIS platform. GIS simply means the combination of spatial data and the non-spatial data. Then urban utility planning. Many services are there in urban area. We can find out those services in urban area and the distribution. Means where the hospitals are there, banks are there, ATM centers are there, where the police station, hmm, where the other offices are there, and how we can access this, how far they are from the particular area. And in future, if the more facility, or if you wanted to establish a hospital or a mall, which are the suitable site where the consumer demand will be the high, that potential sites we can suggest by studying the urban utility services. Urban 3D modeling to find out the illegal location, to find out the vertical growth of the city. We can make the 3D model of the city. When from there we can identify. Here I would like to show the model which I developed of the eastern region of Mumbai. This model we are developed by using the digital photogrammetry technology. You can see this video of urban 3D modeling. This is a model of the eastern region 3D model. We can see how interesting those. We can find out the vertical growth of the city. or we can imagine the, or we can measure the altitude, means height of the building, particular building, and from that we can find out the illegal constructions also. Now here I would like to show one model, GIS model of the Honolulu city, where the remote sensing and GIS is used to make the systematic plan of the Honolulu city. This is a use of remote sensing into the urban geography. This is we can say that GPS survey or use of remote sensing and GIS, and as well as the GPS into the urban research. This is my research work where I identified, I used the GPS technology, GPS, to identify the beams location, dustbin location into this Gwalior city. The red dots are showing the current location of the waste bins in the city, and right side where the bins are not available and people thrown the garbages, their waste into the open place, open dumping side and to the actual bin location. So this systematically shows the special distribution of the bins location and the open dumping site. Open, you can say that where the garbages are dumped on an open area. So it shows means there is a lot of requirement of the bins into the city. So through the GIS application, we can suggest the how much requirement of the bins is there, where it is required, and which road we can keep it, how we can collect those by using the network modeling. We can use how we can put the bins and how we can collect it to bring this garbages out of the city. So with this, I hope you understood the principle and the application of um, remote sensing technology, GIS technology into the urban research, into the various aspect in geography. Thank you so much, students, learners. Thank you so much.